Okay guys, welcome to the second Learning Electronics Repair Christmas special, yeah! So, not too much to say about the intro of this one. Here is a 1500 watt ATX modular power supply, which somebody asked me to repair in the summer, and he's like, I want it yesterday. He put me under a lot of pressure to get this fixed, and it all went horribly wrong in the most nasty way, really, yeah. So no more ado about this one. Just get your Christmas cheer, get your Christmas beer, and just enjoy. See you all soon at the end of it. Hey guys, so I've got this beast of a power supply here. This belongs to a local guy who used it to run a mining rig. Well, he has at least a couple of these mining rigs. You see all the stuff on here, yeah. There's a few people do this around here. I think partly because quite a lot of people renting apartments get basically electricity unlimited and water included, so it doesn't matter how much you use, it's just included in your rent, yeah. We had that as well, actually. Funny enough, actually, we have it by the garage. We have like a lock-up, and that has free electricity on the community, so I suppose I could put a few mining rigs in there myself, to be quite honest. But yeah, fair enough, if you get your electricity for free, why not, you know. So he brought me this in. I'm not saying this guy does, by the way, I just know what the situation is here in general, yeah. So 1500 watt. He says he took it off the computer to clean it, and when he put it back on, it didn't work, yeah, or it sort of came on and went instantly back off again. But let's have a look ourselves and let's see what it's actually doing. So I've just connected the 24-way back up again, and let's put the analyzer on, which is now useful. If you didn't see it, I did a video where I actually modified this so that it will power up regardless of what voltage is there, not just when the 12 volts is there, yeah. Even with the 5 volt standby, this will power up now. Yeah, let's connect the power. Oh, yeah, this has like a weird power socket here. You can't plug like one of our normal ones in, but he brought me the power lead, so let me just go find that. So yeah, our analyzer on here. Let's switch this on and let's see what it actually does. So it's powering up, but power good saying 0 milliseconds. I'm sure there is no power good, and only standby is running according to this. Everything else is saying low. So it looks like we only have 5 volt standby. Must be quite a beefy thing, this. I've switched it off, and it takes quite a long time for that to actually go off, yeah. So obviously some fairly hefty capacitors on the 5 volt standby, or on, you know, the 5 volt standby is still running because some hefty capacitors, you know, on the main input, the main smoothie ones. Okay, so it's gone off. Let's open this up and let's have a look what's inside this behemoth of a power supply, yeah. Okay, so I've got the lid off it. It appears to be your kind of regular sort of thing, really. So I can see 3 transformers under here. They're quite hefty ones, though. I mean, you would expect one to be standby, one to be main power supply, and one to be the base drive for the switching transistors. But they're good size, these 3. Look to be bigger than you would expect for that sort of purpose, especially like the standby and base drive. So possibly this isn't, you know, effectively the same topology of other ones we've looked at. I think first of all we need to get a circuit board out of here, and then let's have a look to see what we've got. This is obviously the panel where all the plugs connect onto it. Yeah, that seems to fit to the main board. Solid rather than the electrolytic capacitors, or like this type of electrolytic capacitor. Yeah, power's plugged in on some connector, we can disconnect that easily. And then there's like these little, I can only assume that these are some sort of sensors with these thin wires that sit on top of these chokes. Okay, PFC maybe. Okay, let's get further into it. Let's see what we've got. Okay, so I've opened it up. This is looking like a standby supply actually here. There's like, so this fits in here this way round, yeah. There's like a rubbery heat sinky thing here, but it's like sticky. And there's some sort of sticky goo on some of these power FETs. There's another bit here, so I'm guessing there's more, you know, opto isolators. I can see opto isolators down here. Let's have that off there. See opto isolators. So this is the high voltage side, and the gap runs across here, yeah. And these things are spanning between the high and low voltage side by the looks of it, as are the opto isolators. So these are on these sticky things are on the low voltage side. Ow! And there was some charge in the capacitor. Well, I'm still here, guys. No harm done. It just like tingled across my little finger, yeah. When I dropped it, it hit the screwdriver, and definitely discharged the capacitors, yeah. A bit of drama. That's the first time I've managed to get a shock off one of these things since probably mid-80s, I think. I don't recall doing it since then, yeah. About 1984, 85. So that just goes to show, no matter how experienced you are with this sort of stuff, sometimes you can forget to do something sensible like just checking the capacitors for charge, yeah. Okay, well, there you go. So that's why these things can be a bit dangerous, yeah. I mean, fortunately, I came out pretty unscathed from that one. I'll just have a look at the PCB down here, though, because that's where it fell on the screwdriver, yeah. Okay, so when I dropped it, it landed on my screwdriver, yeah. Here. And that, if you look, nicely matches the gap directly across this capacitor. That discharged it. That's one way of discharging them, yeah. Now there's only like 8 volts in them. I think I came lucky there. This hand wasn't going to anything grounded yet, so it actually just effectively went across my fingertip. Bit of a zap. You need that every now and then. That reminds you then. I'll tell you what, I bet I won't forget to check the voltage in the capacitors again for a good few years. Okay, so let's see if we can figure out then what's going on with this. Let's see what we've actually got. Don't think then that because standby is running and standby shuts down after 30 seconds that it's shut down because it's drained the main capacitors. I don't believe they were fully charged, just by I have had a high voltage shock a couple of times in the 80s, and that wasn't quite so high. I think they were quite 100 odd volts, yeah, but certainly enough to flash across a screwdriver. Right, so this looks to me like find something insulated, yeah. This looks like the chip that runs a standby. See these things with 7 legs on, there's like a gap where like one leg never was, yeah. That'll be the high voltage pin on the other side of the gap, and that'll be running. This is your standby transformer. These two big things that I thought are the PFC are on the low voltage side. So this is your high voltage side, quite evidently, yeah. This is the high voltage side. We proved that. And these big chokes are here, so they kind of looks like they go across here, I'd say. 2 of them. Can't see exactly how they connected, but there seems to be a break, yeah, like a break in the tracks here. So I'm thinking now these are rectifier diodes in parallel, yeah. And then effectively from the diode where the pad is, it goes through the choke and over to this side. Yeah, something like that. I mean, there's just 2 of them, but they might have more than one wire on each. So I think they're chokes, but and then I think they've got sensors on, which may well be current sensing or something like that. And then after the chokes, this is all your smoothing capacitors, yeah. These are your input chokes, possibly PFC, possibly just chokes. There's a bridge rectifier. Looks like there's a relay down here. Maybe this relay needs to switch on the power to the main power supply. Yeah, just a thought. There's a relay. I can see varistor down there as well. Yeah, for inrush current. And I think the controller, this is going to be awkward to work on. I think the controller for the switch mode is down there on a little circuit board, vertical, yeah. I can't kind of see anything else obvious. Okay. And the same on the other side. I can't see any, on this high voltage side of the circuitry, I can't see any chips, yeah, anything to be like a switch mode controller. These are interesting. So we've got 3 obviously opto isolators and 2 of these things, and these things are spanning across the divide, yeah, between the low voltage and high voltage side. I'm interested to see what they are. Just check the port numbers if I can actually get a data sheet. I can't think what they would be unless they're like multiple opto isolators or something like that. I mean, you've got 3 anyway. Let's always see what these things are. Let's see if we can find the torch. Let's see if we can zoom in a bit enough to actually see the markings on them here. Let's try zoom this down, all the way down. Okay, that's it. So, have we got it now? I can see it on the screen. I can't quite read it. Can't quite see that. Let's have a look. You guys are probably looking at the screen much closer than me. I'll use the magnifier. One moment. One moment. Let's have a look. Thing is marked SIB 230BD. SIB 230. No. SIB 8230BD. SI. I'll get you right, it's a bit hard to read. SI 8230BD. Got it. Oh, okay. Yeah, these things are quite fun, and they tell us something now. So they are basically high side and low side drivers. Yeah, 8230. High side, low side drivers. Yeah. So these are driving MOSFETs, or certainly possibly transistors, which are the main switching transistors. Yeah. There's 2 in each package. If we just scroll down a little bit, I'll show you. Here we go. Yeah. So this can effectively, this is your input, yeah, and this is your output side, and this is your high side and low side MOSFET drivers, yeah. It shows it a bit better if I look a bit further down here. Yeah, this is it. So for each driver, you got an input, yeah, silicon semiconductor based isolation barrier, almost surely an opto isolator, really, yeah, and then demodulator and your output. And this happens like so. You've got an input signal like this, which will be driving the MOSFET, yeah. It converts it to this modulated high frequency bursts, which go across here. Yeah, then it demodulates it to the other side, and then back your square wave again. So we can say that each of these is driving a pair of MOSFETs, high side and low side, or it's using for 2 different MOSFETs, yeah. Maybe, you know, like a single MOSFET on the power supply. So now we know that, we can work out more about the way this thing's laid out, yeah. So these rather fun devices are basically doing what the transformer normally does. You know, when you have like your driver on the low voltage side, your pulse width modulator, you have a transformer driving the base of the transistors for the main power supply, and each one of these is kind of doing the same thing, which leads me to now believe this is the pulse width modulator sitting right next to them, yeah, on the low voltage side. This transformer we know is a 5V standby, just by the fact this chip's by, and I bet that diode's your 5V standby there. Actually, is that on the high volt? That's on the high voltage side, but this is your standby, I'm sure. Yeah. So the 3 transformers under here now, 1, 2, 3. 2 big chunky ones and a small one. I'm wondering now if each of these is a voltage rail. So just a bit of supposition, based on what I can see, what you can see now, is that this may be driving the 12 volts, this may be the 5 volts, and this is the 3.3 or something like that. Yeah, 3 transformers. These chips here, effectively driving the switching transistors. Yeah, pulse width modulator, powered by the 5V standby or another voltage on the 5V standby. So next thing we need to do is have a look to see what this chip is. Yeah, power this thing up. Let's see if this has got any power. Yeah, can it send any drive? Is this side of the circuit working? One matter, I'm just going to check these, but I'm pretty sure these are actually just diodes. Yeah. Okay, let's have a look. No, not diodes. Power FETs. You can see there's where the gate is. Yeah, I haven't looked at the port number, I've made a note of it, but you can see there's like a track here. This will be the gate, drain, source drain, whichever. Yeah, and there's a gate. These will be used as rectifiers. So effectively you normally have a rectifier diode, yeah, that only conducts in one direction, but as you probably know, a rectifier diode takes a certain amount of time to switch off. Yeah, that's why we have Schottky diodes, for instance, which are faster. Yeah, but I think now I can understand what's happening with this area of the circuit and what's happening with this lot. Yeah, so I believe these are chokes, coils. Yeah, possibly 4 of them. These are sensors, I'm pretty sure, and they kind of like disappear down here as well. Yeah. That's the high voltage side, but these kind of like go off into like little connectors down here and here. Yeah, and I wouldn't be surprised, possibly just a guess, that it's sensing the pulses of current coming through here from the switch modes. Yeah, and it's turning these FETs on and off, which it can do much more rapidly than the diode turns on and off. Yeah, so effectively this is acting as a rectifier, but it's being controlled. Turn on when you effectively get the positive pulse, and off when it effectively would be negative. Yeah, and I think that's what they are. Okay, that's a bit more of it worked out. I'll look at that part number, I'm sure that's what they are. And this thing, let's have a look to see what this one is. Yeah, this thing, CM6901T. Yeah. Let's have a look at these, but I know the MOSFETs, I'm just interested. And I'm very interested in this, I'm pretty sure this is our pulse width modulator. Okay, much as I thought. The MOSFETs, which I thought originally were rectifier diodes, are MOSFETs, yeah, as I can see at the gate. And it says that this type is optimized for synchronous rectification. That's the name for what I was trying to describe, where you use a MOSFET and you switch it on and off at the right times to act as a rectifier. Yeah, so it only conducts when it's on, effectively, and that's what these are. Yeah, which brings us to the chip, which is just as interesting. So CM86901, basically it's telling us here it's a controller with one frequency modulation output and 2 pulse width modulation. Yeah, so this can effectively control 3 power supplies. The frequency modulation is that type of circuit we've seen before, where we have 2 transistors and the capacitors with the center tap, you know, effectively 2 in series. Yeah, we've seen this a lot in ATX power supplies, and they use frequency modulation to control the output voltage, and then pulse width modulation is effectively normally the type of power supply that has 1 transistor switch in the coil. Yeah, so this effectively can control 3 power supplies. which is interesting again in our case. Gives us a pin out, so we know pin 15 should have power. That's the first thing we're going to be looking at. Has this got any power on pin 15? Yeah. Is it reset on pin 1? So we'll make a note of this now. So 1 is a reset, which I'll just check if it's active high or low. And 15 is VCC. Yeah. And where's ground on this? Ground's 10. Yeah. So that's the first place we're going to be looking. This data sheet gives us some more information. Actually, just show you. Yeah, this is a kind of a block diagram. Okay, so reset or set external resistor converts some signal voltage current signal for blah, blah, blah. When I'm not quite sure exactly what this does from this description. I need to look up some of these things. Okay, we can see what's on there first. If it looks interesting, we'll have to have a look to see if there's a reset effectively. Yeah. This has a circuit somewhere. You can see I'm not familiar with this chip or this type of thing. You know, I'm like you guys. Sometimes I find stuff I don't know what it is, and I have to spend some time having a look. Yeah. Okay, so typical application circuit here. Okay. 380 volts in and 12 volts out and 12 volts out and so on, minus 12 volts. Yeah. And this shows our controller here. Reset, it shows as being held high. The VREF will be internally generated reference, holding this high. And then a resistor to ground effectively. I mean, I'll have to look. Let's see what's on there. Outputs, yeah, so effectively this is kind of showing like what we've seen before, where you have like two sets of MOSFETs, sorry, two pairs of transistors driving a transformer that actually drives the output switching. Ours uses those funny chips, as we can see, those high side and low side isolated drivers. Okay, so that's the circuit. We can come back to this if we need to come back to this, but right for now we want to know if this chip's getting any power. Yeah, that's the first thing we need to find out. Okay, so let's get us powered up on the bench and let's see you know, if we can find that out. I'm sure we can. Oh, one other thing from that datasheet as well, it's also mentioned that this can control a synchronous rectifier, so there's a good chance this thing is actually what's switching these FETs, which are acting as rectifiers. Yeah, this is what's controlling them. Okay, so pin 1 is here. There's a little dot. I'm not quite sure if you can see it clearly, but there's a little dot here for pin 1. So this is pin 15 here. Yeah. Let's see. Actually, that probably goes to somewhere nearby that I can just hold the meter probe against a little bit more easily than on the chip. You know, you don't want to slip if you're doing this sort of thing. It's not difficult to get to there. Does that go to somewhere handy around here? Okay, if I can't see where it goes, I'll just go on to the thing itself. Okay, yeah, it goes to this capacitor. It goes to this capacitor. So that's where we'll go. We'll go on there to those capacitors. Okay, so let's power it up and let's have it to see if we've got any supply on our chip. Yeah, so we're gonna check it here. Obviously, we'll put it onto a voltage range first. Yeah, okay. So let's just switch this on and then let's see what happens with it. Okay. So we have standby. Yeah, we have standby. So what's happening here? What do we have? And we have about half a volt. Half a volt. So in fact we don't have a power supply to the pulse width modulator. We need to have a look to see where that's coming from. Yeah, see what's wrong there. I'll just wait till he stops bleeping. I'm just going to show you the voltage in these main capacitors. This is the ones that zap my finger. Yeah, so let's have a look what's actually on these big capacitors. Yeah, 300 volts. How quickly does that go away? Not very quickly, yeah. I mean, it took me probably 10 minutes to open this thing up, yeah, and there was still a good charge in the capacitors. So that's why it managed to zap me. Best way to get rid of that, I'll just show you. Better than the finger, I will mention, yeah. Far better idea than using the finger. It switched off and yet the standby came back on. I mean, it's actually switched off, yeah. The switch is off. The wire's unplugged. The standby's come back on again on its own. They drop in now, yeah, more rapidly. So just goes to show what zapped me was not the full voltage, yeah. Right, the reason it didn't discharge before is after the standby I actually unplugged this, yeah. So obviously without the green wire connected, the standby can't come back on. Okay, so he's now made itself safe, yeah. That was my basis, that like, well, if the standby goes off, it's discharged the capacitors, and obviously he didn't. If I'd left this plugged in, I mean, I never thought the standby come back on, and then it does discharge the capacitors. So my theory was good, but this power supply wanted to prove better than me, yeah. So that's another good lesson learned there. Okay, so this chip only has half a volt supply. Let's have a look so we can figure out where that's coming from. Well, this is the 5V standby, the back side of the 5V standby, and I've just spotted something here that's interesting. Let's see if you can see it. Oh, there you go. What's that there? Bits of metal. What are these? What's that? That's interesting. With mortar point, what they're doing here? What's this guy cleaning this with a wire brush or something? Okay, this is ground. There's two capacitors here, so I'm guessing this is actually 5V standby. It's here, yeah. What I'm interested to see is there another coil on here? Yes, in fact, so we've got two secondaries, two diodes feeding, one for 5V standby and one the power supply for this chip, yeah. I didn't actually look up. Let's have a quick look to see what the actual supply voltage is for this CM6901T. Well, on the example circuit it shows 12V, yeah, and we got half a volt here. Does the data sheet actually give us a maximum and minimum? Oh yes, supply voltage between 10 and 20. Okay, so that tells us it's not supplied from the 5V standby voltage itself, yeah. It's going to be supplied by another output from the 5V standby transformer, which is going to be somewhere very specifically between 10 and 20 volts, and 0.5, yeah, most certainly ain't. So looking down here, I see three capacitors, you know, 16V and two that I can't actually see. I don't see any diodes here, but I see this thing, which could be a diode, or it could be a voltage regulator or something like that, yeah. Let's go over to the other side of the board and just adjust the focus slightly so it's in focus. There we go, okay. So this looks like a diode to me. Could be a capacitor. Kind of looks at me like it might be a diode, yeah. This is this thing that's soldered, which I said might be a voltage regulator. And it's got 3 pins on, yeah. Two of the capacitors are actually here in parallel. So I'd say that's one voltage. This is ground. So I'd say this is one of the voltage rails here, yeah. Some guns on it. I'm going to clean off in a minute. This is one. I'd say that this is the other voltage rail here, yeah. So what we're going to do now is, we know we've got 5 volts, so one of these I'm expecting to have 5 volts on it, yeah. The other one well, let's have a look. Okay, let's see. Let's just figure out which is which. So this is ground. So this capacitor, one end of this, you'd expect would go to ground. Yeah. My finger's still a bit tingly, by the way. Yeah, that end's ground, and there's no short on this. That's your main 5 volts. There's no short on here. That isn't ground. That's ground, yeah. So this end will be one of the voltage supplies, and this end will be the other voltage supply. Okay, let's have a look to see what we've actually got. So obviously we've removed that bit of stray wire. I mean, was that what's stopping it from powering up? I've cleaned this area now, got rid of the gunk from whatever was here. I've clipped the black leader emitter to this, so I know I've got a good connection, and I know that clip's not shorting something on the other side of the board, by the way. Just keep your eye open for that. Yeah. So let's have a look. So I'm assuming this is probably the 5 volt standby on this one. Yeah. And we have 5 volts, and this one is the other supply, which is 16 volts. So that 16 volts should end up on our CM thingy-my-bob. Yeah, this one, 6901 was it? Yeah, 6901. But it doesn't. So is this a voltage regulator? Nothing on there. 5 on there. No, I'm not sure what it is. Possibly it's a diode. Okay, so we need to now have a look to see how from here 17 volts should get to this chip. Yeah, so let's switch it off and let's do a bit of tracing around and let's see what's there. I mean, you'd expect it probably would go pretty much directly. I don't see why it should go through anything. Okay, let it bleep. It's all switched off. Let it do its thing. Let it switch back on and do it again. And then once it goes off, we know it's safe to touch. Yeah. And let's not get caught out by this particular thing. Yeah. Not in the future. So this is what I can see. Yeah. This is the capacitor with the 16 volts on. Okay. This end, just put my meter onto bleeping resistance mode. Yeah, this end goes to ground, and this end is the positive. There's no shorts on here. We know we've got 16 volts on this anyway. Yeah. This is pin 15 of the chip. Yeah. If I go from here to here, we'll just get onto it. Yeah, I don't see anything. Yeah, but if I put it onto diode mode, I see what looks kind of like a diode junction. 681. Well, if that was just a diode, there's no way this would have 16 volts on. And this have half a volt on because the diode would conduct, yeah? But that's not what I find here. If we go from pin 15 here, there's this thing here that looks like it might be a voltage regulator. Now it's marked either BC729, which suggests it's a transistor, or 8C729. That's a funny symbol. I can't really tell exactly what it's supposed to be. So I do notice that this side of it goes to our pin 15. The middle pin goes to ground. That would suggest that this is the input to a voltage regulator. That's ground and that's the output. When I go to the input here, yeah, this doesn't go to our capacitor. Yeah. So I also can't see where that goes. It just seems to go to 2 capacitors here. It doesn't seem to go anywhere else. And this is surface mount. I can't see any like wires here that would kind of like go through the board, unless I'm just missing it. You know, maybe I can't see it's under here or something. Maybe it's a wire. But we need to have a look around here, see what's on this. Yeah, let's see if we got any voltages here. I think that's the next thing we want to be checking. Okay, so let's go back over to voltage mode. Let's switch it back on again. Yeah, now let's check the voltages that are around here. Bleep, yeah, bleeping. Okay, so once again, I'll just click the negative on here. Okay, right. So this is what I think is the output. Yeah, and that's a half a volt on it. This is ground, yeah, and this is the other side of it. It has nothing on it, and the same on these capacitors, yeah, nothing on the capacitors. So I think we can assume that provides the power to this, unless this somehow like takes the power away if it's triggered by something. But I don't exactly know at this point in time what that is, and whether this input, it looks like it should be an input. It's got these capacitors on it, like input capacitors. Whether this input should be connected to here, 17 volts. But I don't see how it would or why it wouldn't, if you know what I mean. Let me have a bit of a look around, see if I can actually figure that out any further. Otherwise, I need to find out what that device is before I can really continue to diagnose this. I will add, by the way, just show you this as well, that from these capacitors, the other side actually goes to ground, yeah. There's no like short to ground from pin 15 on here, yeah, so it's not like a short circuit. I strongly suspect that this is a voltage regulator, like a 12 volt regulator or something like that, yeah. And this is intended, this is ground, yeah, which makes sense for a regulator, and this is meant to be the input and is meant to be connected to here, but for some reason isn't. So going to ohms range and put it the right way around, so that positive supply coming in, yeah. High resistance, kilo ohms, yeah. Go to diode mode. But we know this doesn't connect there, the voltage doesn't get there, yeah. Okay. My guess is, but it's a guess, that's a voltage regulator, and that pin should connect to here. And somewhere through the board there's just no connection, yeah. Like a bad track. Or something in between, but I can't see, it's far too congested down here without taking a lot of stuff off the board to see how that connection would get to there, yeah. So my, honestly, with this, guys, is going to be find out what that thing is, yeah. If it turns out that is a voltage regulator and that pin is the input, then I'm going to just bridge a wire, yeah. Well, let's see what happens, yeah. It's either going to work or something's going to go bang, I think. Okay, guys, so yeah, if anybody can identify this thing, can you see the marking? It looks like a letter B, but the top half of the B is smaller than the bottom half of the B, yeah. And then a C729. Well, BC729 is a transistor, and I'm sure it isn't, yeah. And 8C729 doesn't find anything on the data sheet. Okay, guys, part 1 finished, part 2 coming, and unless somebody gives me an answer quickly today on what that is, then I'll see you all soon, very, very soon, in fact. Okay, ciao for now, guys. Okay, so 2 things happened over the weekend. One, I got some information on our strange voltage regulator here, yeah, this thing. And 2, I kind of had a realization. So the information I got on this is that it is a voltage regulator, but it's a 5 volt regulator, and this thing needs 10 to 20 volts, and that it's connected the other way around anyway. So this is actually the input pin, this is ground, and that's the output pin. So that is an output, not an input, as I supposed. And it should be 5 volts. As to what it's for, considering we've got a 5 volt standby here anyway, I really don't know, but that's what that is, yeah. I suspect it turns something else on when this chip is turned on, and that real sort of brings me to the second thing I realised, that if I just stuck 16 volts onto here, this might, what, on pin 15 VCC, this may well then run, but it would just run. And the whole point of this power supply is this is only supposed to run when you press the start button, yeah, on the ATX. And I thought, okay, well, fair enough, if this just runs. Maybe the start button's like a reset pin, or not reset, sorry, an enable pin somewhere. So effectively you ground one of the pins which this enables. So power's always on it, but it doesn't run until you enable it. But I had a look at the pin out, and there isn't an enable pin on this, which then makes me think, well, okay then, in that case this must start up when you press the power on button, and it starts up by applying the power to here, which now starts to make a bit more sense. So I thought, okay, well, if that's the case, and this is an output, how does the power get to here? So I had a bit of a look around again, and what I found this time was a bit more interesting. I actually started from this end, so I started from the chip and had a look to see if I could see where this else was connected to. And one place it was connected to is down here. I just got the thing onto bleepy mode. So I had a look to see where this 16 volt actually goes, and I thought, well, if it's not here, what else looks like a voltage regulator? And I saw this thing, so I had a look, and I can clearly see on resistance mode that it goes to here, So I thought, well, okay, if that's a transistor then, so there's an input or center pin and an output, or a voltage regulator again, that from this side, does it go to the chip? No, it doesn't. It doesn't go to the pin 15, but the pin 15 does go to here, 4.8 ohms. Okay, it goes to here through like a really low resistance, and this thing goes to here, the output of this, So I thought, well, what is that? And the best I can come with is it must be a diode. So I've gone to diode mode, and I can see, in fact it is a diode, it's like a Schottky diode, and I can go from there to there. And there's the power. So the power is coming in through this, it's coming from the 16 volts into here, out. I'm thinking this is like a collector emitter, or it's a MOSFET, through this diode and back to there. There's the power, and this will be switched on when you ground like the green wire, and I noticed then very easily from here, this then goes to this transistor. It's obvious it was going to go to this transistor, This end of the transistor is going to go to ground, like the emitter, This will be the collector going to here, and then this will go somewhere to your power in signal. Now your power in signal has got to come from here somewhere. Get back onto it again, Your power in signal's got to come from here somewhere, because this is all the connectors coming off the back board, And in fact it comes from there, So that's your power in on here. And if you look from here, this power in, on the back of the board here, I've got a pin that says power supply on, that one. But that one, go back down to here again, where I can see it coming in, doesn't go to here. So it's looking like the power on signal here, which is what effectively when this is grounded, isn't getting to here. I can't, anyway, from here, easier way to show you is from the green wire. So I'll just get this the right way up, whichever way when the green wire is. One moment. Okay, so there's no green wires on this yet, but if I just take another one as a comparison, I can see the fourth one in is a green wire, which is the fourth one in there, So I know where the green wire would go, and that is going here, power supply on, which makes sense, but it's not going to here, which goes to the assumed base of our transistor. So I've got one or two things happening here. I'll just zoom it back in again. I've either got a break somewhere between the power PS on signal coming to the back of here and to here, or the signal is getting to here via another transistor or something on the back of here. There's some components behind here, and it is there, but there's a problem down here, So the way to figure this out, I think, is to measure here, yeah, and see. I'll power it up, I'll measure here, and then I'll ground the green wire, yeah, by effectively plugging in the plug into my analyzer, yeah, or sticking a bit of wire, whichever I feel like. And let's see what happens, yeah. So we'll do that. Yeah, that's what we're going to do. Once again, we'll power it up. Well, it's not going to bleep now because I've disconnected the analyzer, yeah. I want to see what's on this pin effectively before we ground the power supply on, yeah. And let's have a quick look around here. We should be able to see kind of what's happening, yeah. So we'll just switch it on first and say there's going to be no bleeps. And let's have a look. So I'm on voltage range, yeah. This is pin. This should be the 16 volts. Yeah, 16 volts, which comes in on this transistor. Yeah, and coming out of here, we know it's going to be about 0.6. Not even that. Yeah, let's get onto it. Nothing there. Okay. Strange, I had 0.6 before, but never mind. That's the only thing was trying to be switched on. Yeah. So this will be low because there's nothing there. This transistor should be turned on. Yeah, 4 volts is a FET. So that's what we've got. Yeah, that's being switched on. Right. Let's now connect our analyzer. Yeah. So this is start up. One moment, just on the wire. Okay. Right there, that's on, yeah. Just put the power back on. Okay. So with the analyzer on now, we can look again. So this will be the 16 volts, yeah, coming in. This is going out to our chip, 0.5, yeah. 0.5, yeah, through the Schottky diode. This transistor is now off. No, still on. This transistor is still on. So this point is still high, and that should go low. Yeah, that should go low when the green wire is low. So we've got a problem somewhere between here and where the PS on signal comes in. Yeah, would you agree with that? Okay, let's see if we can actually get at the back of that other board or not. I know a lot of you guys like the Dicky card, yeah, Dicky card. Okay, so bit of old technology this. I'll just show you that, but I'm pretty sure it'll be clear to most of you, yeah. So we've got a 16 volt supply, yeah, and the 16 volt is going to a MOSFET, yeah. Okay, and coming out of the MOSFET is going to a diode, okay, which is then going to our pulse width modulator, yeah, pin 15, which is VCC. Okay, so that's effectively what we've got. So the power is coming through this FET, yeah, and for the power to come through this FET needs to be turned on. Okay, from the gate, what we've actually got is we've got a transistor. There's another FET actually. We've got another FET, and that's connecting to ground. Okay, and the gate of this one must have a pull-up resistor. I mean, we don't know where it is, but there must be a resistor here, and it's got about 4.5 volts on it, yeah. So this is most definitely turned on, shorting this gate to ground, so this can't turn on. And here we've just got about 0.5 of a volt, yeah. The 0.5, by the way, there's another diode here, kind of like facing the other way. So these are both feeding power into this point here, yeah. And I think it might be coming through that one. I haven't really looked exactly where it's coming through, but that's what we have, yeah. Well, I can't see how it would come through here because this is off, yeah. Anyway, that's what we appear to have. Unless this reads like a diode, no, that doesn't make sense. Okay, that's what we've got. So this point here, this goes to the end of here, yeah, and this should connect to the PS on signal, the green wire. So the idea is that this is PS on, yeah, and effectively when you push your switch you ground this point, yeah. In fact, the PCH, the chip, keeps this grounded once you've touched the switch. Unless you hold it in for so many seconds, it lets you go high again. So that's how it turns this power supply on and off, yeah. And we've got some problem between here and the green wire, and that lot is behind here. So I'm going to see if I can get this board off here and see if we can see what we've got and if we can trace it a little bit further. Okay. Well, I've got the plate off the back, but that doesn't help me. Yeah, it really doesn't help me at all. This is soldered to this one. I'd have to take this apart, yeah. And then this is soldered down to the main board. I think if we unsolder this and unscrew a number of screws, this I don't think this is going to come apart very easily at all, yeah. So what I'm going to do, and because I know the guy is quite keen to get this back, I'm going to take a bit of wire from the PS on here, yeah, from here, PS on, can you see the signal? And I'm going to solder the other end of that wire to where the the gate of that FET goes. Yeah, there it is, you can see it now. So this is PS on, yeah, and the green wire is definitely going to here. Well, the green wire that isn't green is definitely going to here, yeah. And between there and here, which goes to this FET, which turns this on, which supplies that, it's broken somewhere. I've just not getting the connection. So I'm going to solder from this one here, and the other end I'm going to stick it onto here, yeah, PS on. Yeah, it would be nice to trace it through the back of here, but it's so hard to get it apart, and I know the guy really wants it back, so I'm going to take that chance. So I'll put the wire on now and let's see what happens. Okay, so I've put the wire on. I was going to disconnect the gate of this and put my wire on, so then I realised actually this will be the pull up, so it needs this, yeah. This is a 47 ohm resistor, by the way, so from the gate we have 47 ohms to this point, yeah, and this point was obviously where the higher, where the gate voltage was coming from, so I'm going to ground, and from here I'm guessing this goes to somewhere, one way or another goes to the 16 volts. That seems to be, via something or other, yeah, probably a transistor or something. It doesn't go directly, about 1.2k to there, so I feel it's quite safe to ground this point. We're gonna find out now anyway, yeah. And then the other end of the wire obviously goes here on the PS on, yeah. Okay, so I think the thing to do now basically is just connect our, well, it's already connected, our analyzer, and just switch her on again and see what she does. Okay, so that's plugged on there. Let's zoom it out a little bit. Now let's see if this now powers up or not. Yeah. Just make sure there's nothing in the way with all the high voltages. That's all fine. Okay. Right, yeah, so that's it. We just need to plug this in and see what it does. One analyzer. There we go. One. There we go. Okay, so that's it. That's what it does. Oh! Well, that's what it did. Okay. That wasn't the best of moves, was it? I think we'll call that one a failure, shall we? We'll call that one a failure. What do you think, Julie? Yeah, definitely a failure. I guess that shows you don't win them all, yeah? Okay, what happened then? And funnily enough, the 5 volt standby is still running because it's as the capacitors do the discharging thing, they started to bleep again, yeah. For an instance, this came on, and then it went bang. And the problem where it went bang is nothing to do with this, yeah. This is a pulse width modulator. This is where I caused this to switch on. So obviously this powered up with that, and then all this went bang as the other side of these drivers. This is on the high voltage side, yeah. Something went wrong on the high voltage side. My best guess here is that something, I said either I've got a bad connection or there's something that's holding this off. There must have been something in that circuit that was detecting a problem and not allowing this to power up. That's what I'm thinking. Obviously, I made it power up, and then it didn't like it very much. Okay. I think that might be the end of this one. I hope that's one of my more entertaining videos, by the way. So I guess you're thinking, why did they upload this one? And the reason being, because I think the diagnosis was actually good. There was obviously some other problem, and because it was difficult to get at that area of the circuit, I decided on my own, that seems like a good way to go, let's do that, yeah. The problem, I think, was on the high voltage side all along. I don't see any reason why this would have blown apart from once I'd started this chip, yeah. Okay, so yeah, let's upload that one. Let's call that a not success. Yeah. And as I've said on this channel, you know, I'm honest. Yeah, this is reality. Yeah, and sometimes reality doesn't quite go the way you'd wish it to. Okay, comments below, guys. Very interested to hear what you think of that, apart from almost electrocuting myself and then blew the damn thing up. Yeah, see you all soon. Comments please. Ciao for now.
So guys, what do you think of that one? Yeah, I mean, come on, as a repair attempt, that one was truly shocking, yeah. But at least I'm still here to tell the tale. I mean, this is what happens, you know. I'm not going to take full responsibility for this. Well, I should, but I'm still not going to do, yeah, because it's Christmas. So, I mean, basically, this is what happens when you know full well, as a technician, that when the 5-volt standby goes away on an ATX power supply, it drains away and it's gone, that all the voltage inside it have drained away and gone with it, yeah. Apart from maybe when they didn't, but anyway, listen, I got rid of the voltage in those capacitors with my finger, and then what was left I got rid of it with a screwdriver, yeah. So job done in the end. And then of course the guy who this belongs to is a miner, yeah, and he's on my back. He needs this fixing like yesterday, yeah, telling me how much money he's losing every hour. So you know, in the end of that, I took a shortcut and there was a short somewhere and it went pop, quite spectacularly pop, yeah. So the next day I had to order him 2 replacement 850 watts because we couldn't get a 1500, and he paid for them and I wired them up together so that they both came on together when he powered his rig up, and he's happy, yeah, it all works. He was making money again the next day, so that was done. So that just leaves me now with a souvenir, yeah, or doorstop or whatever you can do with this lump. It's bloody heavy, yeah. So yeah, one souvenir of that. I hope you enjoyed that video. I hope that's brought you more Christmas cheer, yeah, on this special day. Okay, so all that's really left to do now is to say Merry Christmas, everybody. Feliz Navidad, Feliz Año, have a good new year, and cheers guys, see you soon. Ciao for now.